Hello everyone, it's May the 30th. Took the day off. Did put up some decorations in the home, which is actually really nice. I never had decorations all my life. I think. I mean, when I was younger, my family didn't really believe in it. I mean, what's the point of putting them up? When I was living by myself, and also I didn't really care. But now that we actually had opportunity to put up some decorations, some pictures, some motivational speech, and I'm looking at them right now, and they make your they make your home look different. It makes it feel like home. Like seriously, like looking at them, yeah, I really enjoy it. And also, it took a lot of efforts putting them together, and it's a two people job. It's like it's very difficult to do everything all by one person. So it's like a team effort, and you put it up. It looks really nice. It gives you a really good feeling. And then watch some good weightlifting content, and watch some Diablo. So that's like perfect day. Yeah, gotta spend indoors. Gotta spend with the people that you care about. Yeah, that's what life is. Alright, so today the challenge is this. Check if a string contains all binary code of size k. Given a binary string and an integer, return true if every binary code of length k is a substring of s, otherwise return false. So k2, we want 0, 0, 0, 1, 1, 0, and 1, 1, right? So if it's 0, 0, 1, 1, 0, 1, 1, 0, that's true. That's true. That's false because it doesn't have 0, 0. Okay. So we want substring. So substring of a certain size. We can try to produce all the substrings. Moving window. Can we movie window this? Because we have a length, so we just set up a length, we just move, right? But we need to know all the because given k is 20, that's a lot of numbers. 2 to the 20th, right? 2 to the 20th. What's 2 to the 20th? 2,000. Actually, not that big. 2 to the 10th. Oh. What's 2 to the 20th? It's quite big. It's over a million. So man, probably not. Can do 2 to the 20th. And the goal is to find if it contains every binary code. Well, we can count, right? We can like set it. Set. You're gonna produce a substring and put that into a set. I mean, the substring is only 20 in size. No, I think it'll be easier. We add a value and we delete a value. Add a value, delete a value. We turn into a number. And if it contains everything, then we can use the total count, right? Total number of counts. Like here, the count is 4. If we have 4, then we're good. If we have a count of 2, then it's good. Let's try that. I think this seems to be a viable way to handle this. Right. Okay, so what we're trying to say is we're gonna get a first one. Right, okay, the first one. Oh, hold on. If, because the length, yeah, we say if len s is smaller than len k, right? No, smaller than k. If that happens, return false. So we cannot get anything. Otherwise, then we're gonna get int. So I'm gonna say n. I'm gonna say num equals int s k. The first k, then I think that's binary. Okay, and we say s. No s. It's a num set. It's going to be a set. Okay, and we just say for I in range. So we get the first k. So that's actually from k to len s, right? That's what we're looking for. All right. So what do we do? Oh, hold on. So this is actually we're gonna do num. Okay. So num is inside. So now what we're gonna do is remove 1 plus 1. So we say num shall equal to num minus a value minus what? Minus something plus something, right? So plus something is easy to do. So let's do plus something first. So plus is I. So we say int si, right? And that's it, because it's either 0 or it's either 1. Now here, if that's the case, then we don't need this. We don't need this, and we also don't need this. So in here, it's going to be int s, oh shoot, s, what's that? That can be I minus k, right? Because, hold on, we'll start with k. I minus k is 0. Yeah, so that's that. So that thing multiplied by 2 to the power of k. Is that right? To the power of k. No, 2 to the power of k minus 1. Because if you have 4, and the first one is to the 0 power 1, 2, 3, right? That's what it is. So that's the first position. So it's 2 to the k minus 1 power. So we have the new num. After that, we just say num set dot add num, and then keep going. Once we're done, we say return len num set is equal to 2 to the power of k. Okay, so let's check. So this one shall be true. This one is true. It's false. This could be S and K. So S and K. First one. All right, let's see what happened. Print num set 0 1 minus. Oh, minus. 0, 1. Hold on, that's a 0, right? And then that's 1. And that is not right. Oh, shoot. Well, I forgot. Oh, hold on. Yeah, this is not right. I need... I don't need to... I just need to remove that. The left shift 1. Okay, so this is not right. So we need to do this. Oh, actually, I don't need this. Right. So num minus this. Wait, hold on. Num minus this times 2 to this. Okay. And then the whole thing. So after remove, and then when the left shift 1. How many parentheses can you have? There we go. We need to left shift. Alright, let's see if we consider all the cases. Oopsie doozy. It's so slow. You have been awarded the May badge. Okay. Don't really care, but it's so slow. It's so slow. Oh, I see. Speed bump. I'm calculating this every single time. P. So now this one become P. Right. And then this is P divided by 2. What? Nope. Multiply by 2. That should be faster because we're reducing a lot of what don't do the repeated computation. Yes, but still slow. Okay, it's still slow. So you're telling me the one I do basically is just string it? It could be. Maybe I did string it. Oh shoot. Press the wrong button. So sliding window to compute each binary code value of length k. Should be on, right? But it's quite on the slow side, so when I need got the percentage, it's pretty low. All right, so I'm gonna write the other one with it's right here. Terrible. Like I don't remember, like 10%, 10 to 20%. That's pretty bad. Okay, so let's Let's try something different. I mean, not anything special. It's just again, I did this one as well. Oh, maybe in this one I only have to. Yeah, maybe I don't even have to. So I just need to do, let's say, for str set, right? And then we say for I in range k minus 1 to linus, right? And then this comment here, this, so we just say str set add s from I minus k plus 1 to I plus 1. Are you sure? Why don't you just start with this? That's like the starting point. No. I pick the end point. Okay, I pick the end point and then we go back k times, but have to plus 1. And then, yeah, well, let's do this. So, this, and then we say return line num set p, okay. Must be integers. Oh, it's not num set. Set. P is not defined. The heck are you doing, man? Faster. This one is faster. Slightly. Alright, show me. What did I do in the past? Directly put use set on substring. Okay, 296. That was way too fast. 196 test cases, so fewer test cases. Ah, okay. So that's the same as this. How about this one? Rolling hash. Oh, rolling hash. I think rolling hash can make it faster. Hash map. Hold on. I don't remember rolling hash. So hash map, we got all ones. hash map key. Oh, that was my idea, my first idea. Key left shift 1. Okay. And all ones. Oh. That's exactly the same as this one. But I don't have to do this. So instead of doing the I'm gonna do this. Instead of doing the arithmetic, I shall take advantage. No, that's 3. So what should we say? So this is the same idea as solution 1, but using bit manipulation to compute each new value of k length binary code faster, right? So we still do this, and we don't do this, man. I still want to use a set, okay? I still want to use a set, but all ones, that's needed. So 1 left shift k minus 1. Alright, that's all ones. And then now we go this equal to this. So instead of doing this, I think I'm just gonna delete everything. What do we have? So we have num need to left shift to 1, right? And then and all ones. So this guarantees we'll remove the first, right? We'll remove the first thing. And then we can all int as I, the current one coming in, and then we'll add it to. And then we can just say all ones plus 1, right? Hold on, what are you doing, man? All right, let's see if this one works. I mean, just keep in mind, it's not going to be as fast as the last time because we have changed the number of test cases. Still worth a shot. It's similar to this. Okay. So that's that. I think we have finished that. Turn this off. So we have 697 days. We're getting closer to 700. The goal is to hit 1,000, but that will have to take a while. Okay, we've done this for 24 minutes. Okay, let's just start cracking on this. This is a difficult one, so it'll probably take a while. Let's see. You're given a zero-indexed 2D integer array grid of size m by n, which represents a field. Each cell has one of 3 values: grass, fire, a wall. You and a fire cannot possibly escape the spreading fire. You're situated in the top left corner, okay? And you want to travel to the safe house at the bottom right. Every minute, you may move to an adjacent grass cell. After you move, every fire cell will spread to all adjacent cells that are not walls. What does adjacent cell mean? Return the maximum number of minutes that you can stay in your initial position before moving while still safely reaching the safe house. If this is impossible, return -1. If you can always reach the safe house regardless of the minute stayed, return 10 to the 9th. But even if the fire spreads to the safe house immediately after you have reached it, it will be counted as safely reaching the safe house. A cell is adjacent to, and if the former is directly north, east, south, or west. Sides are touching, so there's no diagonal. Okay. Very interesting problem. So we're starting with here. So we want to go to the safe house, and we have fire here. So fire, like this fire, can only spread here. But remember, each time it spreads, new fire can start spreading as well. So 3 minutes. So we go 1, 2, 3. So this one we go 1, 2, 3. Yes. And then another minute. Reaching here, reaching here. Another minute. We're reaching here. Another minute. Holy guacamole. So I'll put a 3, you can wait for 3. Okay. Immediately move towards the safe house. Fire was spread. So if we move, fire will be here. Boom, hit it. Boom, hit it. Wow, you can always have stars on the safe house. Holy guacamole! This is a very, very interesting problem. How do we model this? And the behavior of the fire is tough because it's not just the initial fire, right? It's initial fire and the continuing. Every single fire will have this before. Will have this thing going on. I mean, if we have a state, right? Like, this is a state after 3 minutes, and then we're trying to see if it's possible. Oh, and it's not static, right? That's the thing. Like you say, I start moving in 3 minutes, and how do you know you can reach the safe house? How do you know? Which means the leading. All right, here's a hypothesis: is you always need to move to the safe house with the shortest path. Well, actually, in fact, in this scenario, there's only one path. Like, this number of steps is determined. It's just the Hamming distance, right? Not Hamming distance. The Manhattan. It's the Manhattan distance. You have to take, I don't know, how many minutes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? You have to take 10 minutes, which is just the number of cells. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no, is then after this to this And no matter how you do, you have to move right. Like in this case, you have to move right 1, 2, 3, 4, 5, 6 times. Move right 6 times and move down 1, 2, 3, 4. And move right 6 times, move down 4 times. So the number of minutes you will spend going around is determined. So this just means, because we want to see if I can compute, right? So and this just, that's not m, so m plus n minus 1, right? Because this m is 5, n is 7. 2, 3, 4, 5. 5 plus 7 is 12. Minus 2. Or minus the start and minus the end. Because we don't have to go, because that's the first move, right? That's the first move, and that's the last move. And then so n plus n minus 2. M plus n, this one we have to have 1, 2, 3, 4. 1, 2, 3. 3 plus 4 is 7 minus 5. 1, 2, 3, 4, 5. Yeah, we have to make 5 moves, at least 5 moves. And it is also possible that they can get blocked, so you never make it. So anyway, maybe we should first check if there is a path, right? Like, just at the initial situation. If the initial situation there's no path, then there's no way, right? How do we do that? Basically, we can just say, yeah, we can simplify, because you don't want to go back. You don't want to waste time, because you waste time, then the fire is going to spread. They're going to cut off more of the road. What's the point? So you want to go the fastest, so you only go down or go right. So we can find the fastest way to get there. Just to see if it's possible. I mean, we can do this. DFS, I think, is the easiest. So you only go right and go down. That's it. You don't even have to consider the path. Just go right and go down. And for each one, go right or go down, go right or go down, and see if you can reach it. If you can reach it, that means at least we have a path, right? We have a path, and then we might have multiple paths. Maybe that's the case. You find out all possible paths and just check if this path works, right? So in this case, actually, there's only one path, right? In this case, there's only one path as well. In this case, we have only one path. So when we find out all the paths, okay, now we need to see if the fire can reach these paths. So now what we have is at each minute, I know exactly where the person is, right? I know exactly where the person is. Okay, so can I now start from the fire's perspective? Okay, we start from the fire's perspective and see, let's say after 1 minute, where is the fire? How many cells are inside? So, okay. We start from the fire initially, and after a minute, we're just gonna grow, right? They grow. And after they grow, if a fire is surrounded, no, the fire that grows out, that fire is gone, right? Because it doesn't make any more difference. So after we grow, it's like a what should I call it? It's like a queue, right? It's like a queue for the fire. So we start from some fire, and after a minute we extend, right? We extend, and we put all those into a set. The extended fire into a set, but also have the overall fire as a set. And then when we have that, So like that's the after 1 minute, and then we know all paths that works. So all of them, we can go one by one to see if they are inside this fire. If they're in the fire, that means it doesn't work. So we go select the one that's not in the fire. So we can have like two queues, right? One queue is the fire, and one queue is the fire, the current front line of the fire. One queue is the current step. And then, BFS. Two BFS happening at the same time. Two BFS happening at the same time. One BFS is the person, the current step, because there's always going to be a queue. The other BFS is the fire. The fires are going as well, so it's the fire. And every time if a fire can move on to the next one, we'll put a new one in. If it cannot move, and then we just don't put it. But they're all put inside a huge set, and that set contains, I mean, it's 2 times 10 to the 4th. It's not that big, right? So they're all put in a set. And then every time we just check all the current step, see if they're in the set. Anything that's in the set it's not gonna work, right? So okay, but that doesn't solve the problem of how much time we can wait. It just solve the problem if we start moving initially, if we can reach. That's only solve that problem. But what we can do is at each minute what you're saying is we need to compute the front line, the minimum distance between the front line fire to really like here, right? The front line fire, the Hamming distance. Oh, but the Hamming distance, it also got blocked by the wall. Let me think again. So I can produce minute after minute, right? Minute after minute, the fire's state, like which cells are consumed by fire. I know at the first minute, at the 0th minute, like at the 0th minute is these two. At 1 minute, I have whatever. At 2 minutes, I have whatever. 3 minutes, 4 minutes, all the way until it fills the entire grid. I can do that. Okay? Now, the question is, start from which minute there's no longer a path, right? That's the question. So I mean, we can use binary search. Let's say I wait for a certain number of minutes, and then I can check what the state is, how many cells are occupied. And then I need to see if I can reach. So I run a DFS, right? I run a DFS. Actually, no, I don't run a DFS. I need to run a BFS. So I run a BFS, I come out, and then the next minute, so at each minute, the number of cells that you cannot reach just increases. So at each minute, you want to see if this is good, and it's no longer good because the set just increases. And then you know if it's possible or it's not possible. And if it's not possible, then you reduce the wait time. If it's possible, to increase the wait time. And until and you have the maximum wait time. Yeah, we can just set it to 10 to the 9th. That's fine. It'll get there in pretty fast. Let's try this. Might work, might not work. Alright, so we're gonna try this method. If it works, then all the glory to me. If it doesn't work, then we stop today and check the hints. Okay, so what we want to do is I want to create the state, a fire state. So fire state is going to be, so fire states, okay? Fire states is going to be a list of set. So, right, initial is going to be, oh Lord, I don't even know where the fire is initially. Maybe we can just copy 10 to the 4th. I don't know. Maybe it's either doing that way. I don't know. Grid. So we need to copy the grid. That's what I say. It might not be the best idea. Hold a second. I need to find out the initial fire state. Which cells are fire, right? So in this case, I'm gonna put a set here, okay? And I'll just say for, I have to traverse through the entire thing. Is this the best way to do it? Is this the best way to do it? I think we gotta try. For I in range, oh, an mn. And we'll always have because 2. Okay. I in range m, j in range n. Okay. So let's say if grid ij is equal to, what's fire? Fire is 1. Then fire states 0 dot add ij. Right. So now we populate the fire states. Now we're going to populate the rest of the fire states. So the minutes, right? The minutes. The minutes. Gosh, how do I copy a set? You're talking about copying a set. List it, copy it. And tuple is immutable. Actually, I'm not sure. Let's try this. It's a good question. If A is equal to a set, 2, 3, 4. Okay, A is unsubscribable. A can copy. Okay. I don't know, 5, 4, 5, 6. Okay, so I can copy. All right, and we say what? Well, true. I don't know how many minutes it can last. So we're gonna say the previous state, that's where we start from, right? And we'll go through them one by one, which we can. We can go through them one by one, and then we'll find they can expand, right? That's the queue. Okay, the queue. Oh. And it would expand to new things. The new things will become the new queue. Oh man, how do I handle this? The new thing will become the new queue. So we're gonna have a queue which is made up of this previous, no, that's a set, right? And then we go out. If it's good, they'll put into a temp. And go out, I'll put in a temp, go out, I'll put in a temp. And then we'll have a temp, right? And then this temp set and a previous set. Oh, hold on, maybe we can do, hold on, let's say A dot union B. That's a new thing. Yep, they're all okay. That'll be interesting. Hold on, say Q will equal to fire states 0. That's initial Q. And we say while Q temp is equal to a set. We'll use set for this. Okay. Then we just say for ij in Q, right? didj for didj in, well, we have 0, 1. 0 minus 1. 1, 0. Minus 1, 0. Alright, ni nj equals I plus dij is dj, right? If 0 is smaller equal to ni smaller than n1, 0 is smaller equal to nj smaller than n, and grid ni nj is equal to 0, right? Because if it's already a fire, we don't go there, that means we're already spread there. If it's a 2, we cannot go there, so we will only go to 0, okay? So if this is the case, then temp.add nij, okay? So when I go through this, blah, 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 when we hit, because these are the new frontiers, okay? These are the new frontiers. Then Q will equal to temp, and fire states that append fire states minus 1 dot union Q. Yep, we'll put them together. And then we'll go again, go again, go again, until we don't have anything to give. Okay, so that's, alright, we need to, it's a tough problem, so we have to be more careful on what we do. Basically, this means I want to test along the way. So we have grid. Now it doesn't matter if it's accurate or not, but I just want to make sure that it makes sense. Okay, that's all I want. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, so grid. Max 1 minute. Grid. Oh shoot. We have some issues. Print fire state. Yep. What's the problem? Oh, and this equal to 0, and ninj is not in fire states minus 1, because if it's in there, right? If it's in there, then we are repeating ourselves. Okay, so that's that. We'll start with this. Yeah, we actually check. We start with these two, and then 1 minute we have 2415, and then we go to 2, 3. Yes. 2, 3, 2, 4, and 2, 3, 2, 4, 5. Hold on. That doesn't make any sense. Why you only record to 1.5? That should be the first minute. 2.4 does extend to 2.3. For 1.5, I should extend to 0.5, right? How? ij in q, okay? di dj equals this. ni in j is I plus, temp.add. Let's not do this. Let's print q here. That is correct. No, that's not correct. What a load of crap. Starts with this, and you give me only this. How? Two, 5. 2, 5. Two, 3. Oh, my bad. Yeah, sorry. Put them on the wrong spot. Okay, so that's your state. Okay, so we got a fire state. Now what? Now we have a fire state. Now the battery such. So low, high equals. What is low? Low would actually go a negative value. I don't know, like if what if you set up a -1? I go to 0, so I have minus 1 and 0. 0 works. But we want to, if it works, we want to keep going down. So minus 1 plus 0 is minus 1 divided by 2. Yeah, if 0 doesn't work, like if 0 works, we want to go up. If 0 doesn't work, we want to go down. Minus 2? So there's a bias towards the low, which we want, right? We want to find the maximum. No, maximum we want to go towards the high side. So like these two divided by 2. Low need to be plus 1. High need to be stay where they are. Man, I hate it every time this. And there is some formula in this, but I'm not 100% sure. Like what I'm doing right now is just a basic binary search. If we want to find a maximum possible. So if it works, if mid doesn't work, right? So we say high need to go down. If mid works, then low need to be plus 1. And eventually when it goes out, right, is because it's too much. If it doesn't work, shouldn't you also say this? If the low is too small, you don't do it. No. It doesn't work. So here, or we go to 0, doesn't work, go to minus 1. don't know the, let me just say if mid is smaller than 0, and break. Then mid is the number of minutes I wait, right? Then 0 minutes, 1 minute, so we have the fire state, it just starts from mid. And we have another BFS, so we can say Q go to current state, so about 0 and 0, okay? And then we say while Q temp equals this, and then we say for ij for dij, we're only gonna go down and go to the right, 2 directions, right? Go down, go to the right. Nij equals I plus di, j plus dj. 0 smaller equal to ni small m, and 0 smaller equal to j smaller n, and greater than nj, nj is equal to and nij. Not in fire states. Fire states mid. So that's the current fire states. If that's the case, right, then we say temp.append nij. Okay. Append. Okay. We might have duplicates. Seriously, we might have duplicates. They might go to the same thing. So why don't we turn this into a set? Okay. Yeah, we're just going to turn this into a set. Q is going to be a set. Okay, Q is going to be a set. Everything is a set. Blah, blah, blah. Now this is not append, this is add. Right, and then we say if ni is equal to n minus 1 and nj is equal to n minus 1. Right, then since it's we can handle it outside. Right. So once we're just done, we say Q equals temp, right? And we can just check at the start. I check here. Doesn't matter. Say if n minus 1 in Q, then we break. Okay. So we'll do else. So when break or else, else means we go through the entire thing. So we keep going until a point we don't have Q anymore. That means we haven't reached, right? That means we waited too long, right? We waited too long. So we need to reduce the amount of wait. So we say high shall equal to mid. We waited too long. We reduce the amount of wait and continue. Okay. Otherwise, then we'll see because it's breakout. If it's breakout means we reached, right? That means we can wait a little longer. We'll say low equals mid plus 1, right? Low equals mid plus 1. Okay, low equals mid plus 1. And then we try it again, right? We try it again, try it again, try it again. And eventually, high equals mid. Then we try it again. And then we can try it again, try it again, try it again. Still no good. So eventually, because we get the mid, it's biased towards this, right? Now we say this one is good, right? If this one is good, then this is good, okay? Then we do this, too much. So from here, do this, too much. Then we do this, too much, and eventually we will go back to low. There's actually some repeated computation here. But it's based on different way. Oh, I forgot to. Mid has to increment. Mid plus equal 1. Oh. No. Hold on. So tick equals mid. Shoot. And then I think I have another mid. Yeah. That should be tick. And this is tick plus equal 1. Yeah. Tick. There's a way different tick to go, so it's different. Okay. I think I'm now stuck on the binary search part. So high equals mid. I feel like it's right. Low equal to mid plus 1. Right, we try to go on the higher side. Okay, so low, that means it works. So low, we want to go a little bit higher. Right, so low equals mid plus 1. Then what? Low equals mid plus 1. And it fails. Yeah, so hold on. So mid works and the low becomes a mid plus 1. And then it fail all the way to low. Then we need to check if low works. How do I know? Okay, hold on. If mid works, always low will go up. If mid works, which means low mid works, so mid plus 1, right? And then eventually it merges. Yeah, if it works, until a time that low and high are the same. And how do we know that it is not? Maximum number of time to wait. eventually these two merge, right? This works. Low. It still works. Go here, +1. If it still works, go here. Eventually we'll hit a point where this doesn't work. So the idea is high does not work. So once that happens, we go low need to go -1. Does that mean we just need to go this +1? And then as we go, eventually come out. And turn low to -1 if low is smaller than 0, else low -1. I don't know. Out of range. Huh. Ooh, out of range. Wait, what the hell is out of range? Waited for too long. Oh, we have a maximum wait time. We cannot wait more than this. More than that. If we wait, yeah, that's the maximum wait that it will fill the entire thing. Right, that's the maximum wait. So the high, you're telling me that the high is going to be land fire states. I don't know. So wait for 7 is not gonna work. So now we're gonna wait for 2. Wait for 2 works. So we're gonna say now we're gonna wait for 2 works. So now log becomes 3. 3 7 wait for 5. Wait for 5 doesn't work. Right? 5 doesn't work. I'm gonna wait for 4. And we'll wait for 4 minutes. We'll wait for 4 minutes. And it shouldn't work, right? If 4 minutes, it shouldn't work. High should equal to 4. I don't understand. Wait for 4 minutes. I got. Hold on. This is not right. This is not right. Wait for. Hold on. Maybe we should go tick. Oh man. Wait for this amount of minutes. 1 minute. Maybe we should be tick. We'll do this. Okay. Hold on. Okay. This does not pass. Why? Because this hit the end. So I'll queue. Length fire states. Okay. Length fire states. So while queue and tick is smaller than length fire states. Then do this. Otherwise won't come out because tick. So fire has spread through the entire thing. That's not right. So we come out, and this is considered a fail. No, it means we still have Q, but we have exhausted the tick. Right? We cannot tick no more, so file doesn't go any longer. Let's see. I shouldn't put it here. No, I don't think so. So while Q, right? Blah blah. This one. Okay, so this is first, right? Now we say if tick is smaller if tick is smaller than len file state, and if tick is smaller than this, and this is in this, or tick is equal nope. I don't like this. It's not what I want. Shall be the minimum of tick and len fire state minus 1. So we say if this, else if low is smaller than len fire state, else 10 to the 9th. Okay, it works with these, so we're gonna try it. Likelihood of this not passing is huge. Likelihood of it passing is small, but we're gonna take a shot. If it doesn't work, we're gonna solve it tomorrow. Try it. It's still going. It's still going. It's still going. I got a wrong answer. Okay, let's see if we pass any. We passed 35, 38. So it's not too bad, but okay, I think it's more than 1 hour, 1 hour and a half. Yeah, I'm gonna call it now. This is hard, but I feel like we can do this, right? Output -1, else low -1. What is, so this 0, expected is 0. I don't want to give up. I don't want to give up as of yet. I feel I have a little bit more in me. Okay. So we are going to check on what on here? No, let's do here. Low, high, and then mid. So low and a high, 8, too much, so it goes 3, and then too much, or 3, and it becomes 0. Mid is 0. Mid is 0. And the 0 is not good because the tick. What did I think it's because one of them failed. Yeah, the first one failed. That's why I chose +1. Wait the amount of time. It should be mid, because that's the amount of time I wait, right? Let's wait for 0 minutes and 1 minute. And basically it just says, and wait for 5 minutes, right? And now I have this state. So after 5 minutes, that's the state. And then from that state, we start going on. I think maybe here. Shall we take +1? It doesn't fit. Like one of them was right, the other one is not right. Tick, that's the amount of time you wait, right? You wait for this amount of time, and then you start to go. You move to the next one, right? That's the next one. So tick need a +1, right? And then after that, take +1 and take +1. That makes sense. But in this case, you start waiting is 8, 3, wait for 0, right? Mid is 0, and then you wait for 0 minutes, okay? You wait for 0 minutes, right? Now your wait is 0 minute, and then you start. I don't understand. You wait for 0 minute, and then you start, and you +1, right? You have to +1. So we can draw this. 2, 3, 4, 5, 5. 5 by 5. 2 is a wall, 1 is 5. 2, 2, 0, 2, 0, 0, 2. If you wait, this is 0 minute. 1, 2, 3, 4. Oh my god. Take 8 minutes to get here. 2, 3, 4, 5, 6, 7, 8. So, well, go 1, 2, 8. They reach at the exact same time. I think the problem is I know why. They can reach at the same time. So if this is 0 and ni and j is equal to m minus 1, n minus 1, or it's not in there. Now 0 is good, right? And 0 is good. And we go to 1, 3, and 2. 2 is bad. 1, 2. And then 1 is bad. Become 1, 1. So common out shall be don't understand. What's low gonna come out? Low come out is 2. It has to. Oh no. Hold on. It must just arrive. It's a very special case. If this okay, if they're the same, that's actually I don't need too many. So just say equals minus 1 and nj equals a minus 1, and it has to be the new thing, and m minus 1 n minus 1 is not in, okay, not in fire states tick minus 1. Okay, so this just means the current is the end, and the end is not in the previous fire state, which means the fire state is allowed to reach the end in the current tick. So if that's the case, then we add it. Oh. What's the problem? It's not going to be this. It's got to be tick minus 1. how is tick -1 gonna be out of range? Probably -2. Okay, max. What the heck? What's... Oh, -1. My bad. Okay. Let's try one more time. Alright, if this one doesn't work, then I'm calling quits. Come on. Come on. Edge case. Edge case. We can handle edge case. Yeah, I was thinking about this edge case actually earlier. Didn't. So this should be... So what happens is we don't have a line, right? So we probably, yeah, for binary search, we say if not len. Actually, this is not going to be here. If not len. No. We can say if not fire this, return. That just means there's no fire. We have fire states. How do we have fire states? We don't. Oh my god. It does have a set in it. Jesus. Okay. Makes sense. Check here. If not fire states, turn to the ninth. So these two lines more time. Nope. I'm calling quits now. Been too long. Probably close to 2 hours. Yep, so tomorrow we're gonna take a look at the hints and then go from there. Alright, see you guys tomorrow. Adios.